Hello everyone, Magic Kizanaji. Today I am here to explain you about the evaluation of the NoSQL databases for OLAP workloads. Let us move on to the introduction. Basically, let us know about this statement that evaluating a new SQL database for OLAP workload. So basically, we are making use of databases like MongoDB, Redis, Apache Kudo, and AragoDB for OLAP workloads, and we are making use of these performance for the OLAP workloads as a benchmark. So we make use of a standardized pipeline with Apache Sparks for the better data processing. So the main agenda is to identify the optimal NoSQL solution for analytical processing at this scale. Moving on to generic pipelines architecture, there are three generic pipeline architectures, that is data processing, data store, and data analytics. So in data processing, the storage of the raw data will be in Apache HDFS, and this Apache Sparks handles the transformation and the data loading. Moving on to the data source, NoSQL databases like MongoDB, Redis, Kudo, AragoDB serves as a data warehouses. So moving on to the data analytics, in this the business intelligence tools it will be connected to the database for the analysis and the visualization of the data. Moving further, let us know about the data model and how the data is processed. There are two types of data model, that is Snowflake model and the flat model. The Snowflake model is used for the PostgreSQL and it contains the component facts and relationship of the table. The line item is the central part of the table. Moving on to flat model, it is used for the NoSQL database, and it simplifies the schema by involving all the attributes in the line item table. So moving on to data processing, for optimizing the parallel processing across the available resources is make use of a Spark num partitioning feature. Let's look on to the performance of the MongoDB. There it depends on the three factors, that is data loading, query execution, and aggregation performance. In data loading, as the data set size increased is due to the higher data ingestion time in the MongoDB, and it has been progressively shown. So in query executions, for the efficiency of the queries, which has to be handled with a 0.8x increases for every 2x data increases. So aggregation performance, due to the cause of document lookup and the computer operations, there is a struggling with a intensive aggregation queries. Let's look on to the performance of Redis. It depends on the three factor: data loading challenge, second is a schema impact, and third is the query executions. In data loading challenge, the main uh, performance is slow. There is a poor performance due to the increase in the data loading time, which impacts the display of the Redis. So moving on to schema impact, making use of a single key with more than 40 values, which causes the inefficiency in the memory usage, which slows the retrieval. So query executions, as compared to the other data sets, databases, there is a consistency slower query executions with regardlessly of the data set size. Moving on to ArangoDB performance, the factors are data insertion, query execution, and query optimization. In data execution, excessive the insertion time, the scaling is poor with a larger data sets. So in query execution, 1.5x increases in the execution time for every 2x data size increases. So query optimization, dynamic optimizer selects the effective execution plans based on the query complexity. Moving on to the Apache Kudo performance, compared to the other database, that is NoSQL database, The Apache CUDA performance has a good impacts, like it has a more advantages compared to the other databases. Firstly, the fast data loading compared to the all the other databases, the Apache CUDA has a loading time a smallest across all the data. Like it has a in small span, it can load all data. Moving on to query efficiency, it has a best query execution performance among all the other databases. The columnar storage advantages, it mainly used for and it is efficient for the analytical workloads, and it minimizes the input output operations. Let us know the comparisons of the SQL with, that is PostgreSQL with a NoSQL database. So PostgreSQL has a increase in the data loading with the scaling. In a NoSQL database, there is a varied performance. Moving on to query performance, there is efficiency for filtering and aggregation in the PostgreSQL. In NoSQL database, it's generally faster for the complex queries. Let us move on to future enhancements. Columnar storage dominance. A columnar database like Kudo showed superior performance for OLAP workloads, and NoSQL scalability. NoSQL solutions demonstrated strong scalable capabilities for complex analytical problems. The future research recommended future investigation of the columnar storage dominance integration with the analytics.